Hello AP Stats. This is the video for chapter 10 and 11 tests. Hope that after this video, you will be able to understand how to get the confidence interval as well as the testing for means using Z or T test. Let's get started with number one. Number one, to access the accuracy of a laboratory scale, a standard weight that is known weight to 1. Weight total n times the mean x, blah, blah, blah. And then we have the unknown mean, the standard deviation. Okay, so this tells me that I have to use a z because a sigma is given. How large should the n be so that the 95% confidence interval for mu has a margin of error of plus and minus 0.0001? So that would be your margin of error, which will be the same formula as using n and dividing by the square root, but you need to have the sigma in there. Remember that for every significance, the confidence interval, it's the mean plus and minus the z times the standard deviation over square root of n. Now, that whole thing will be considered the margin of error. Since we have a 95% confidence interval, we can do inverse norm with the area of 0.975, 0, 1. This gives you 1.96 for the z-score. And the sigma is given to us as 0.01. So if I were to just set them equal to each other, 1.96, 0.01 square root of n, and the rest is history. So you just have to use the algebra to solve for this. So I'm going to use the calculator on this side real quick. So 1.96 divided by, 0.0001 divided by 1.96. And then 0.01 divided by the answer. And then when you square that, that should give you your n of at least 38,416. So that should be the answer for number one. I think the biggest takeaway here is that you're supposed to be using a z-score because the sigma is given to us. Number two, the government claims, blah, 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 we have a confidence interval of 95% and the correct interpretation. If the study were to be repeated many times, there's 95% probability. Now remember, confidence interval, you never want to use the word probability in any of your answers here. So I'm just going to automatically eliminate A. Because a specific confidence interval does not contain the value 4,500, there's a 95% probability the true average summer earning is not, again, 95% probability, right? Then about 95% of all the confidence intervals will contain the value of 4,500. This one I'll just put it aside for now. If we repeat our survey many times, then about 95% of our confidence interval will contain the true value of the average earnings of the students. Okay, first of all, D sounds the best. True value, it's going to capture 95% of our confidence intervals. This sounds to be the best answer. There's a 95. Okay, so first of all, there's the word probability for E. If we were to repeat the survey many times, then about 95% of all confidence intervals will contain the value of 4,500. It's not a guarantee. We're not talking about 4,500. We're talking about the true value of the average earnings. This is just a claim that they have made. Therefore, the correct answer here should be D for number two. We are given a confidence interval, and let's take a look at the standard deviation of 95, random sample of 30. So the standard deviation is 95, we divide by square root of 30, and then it doesn't seem that this is going to be a z-test because this is standard deviation based on sample. So what we're going to do is we're going to actually use the t value. This is actually equal to 47.8. So let's do the math here. 47.8 times the square root of 30 divided by 95. That should give you the t-value 2.755. Now, one of these answer choices should give you a t-value of 2.755. But what you can do is you can actually go on about doing the inverse t. And then let's say I check for the first one, 0.95. You should know that because 90% in the middle. And so that will be 5 on either end. So that will be an area of 0.95. A degree of freedom of 29 because the sample size is 30. Okay, that gives me such a low t-score. So I'm going to try to see if 0.99% will work. So I'm going to put 0.995. And that is 2.756, which is the closest one that we got to the t-value that we have calculated from before. So number 3 here should be C. Number 4, we have a confidence interval 5.9 to 8.3. If you were to add these together, you get 14.2. Divided by 2, you get 7.1. The reason why we want to find the average of these two numbers is so that you can find a halfway through. So 7.1 is like the middle of the two confidence interval values. And the margin of error is how much you go from 7.1 to 8.3, which is 1.2. So that should be D. 99% confidence interval for sugar content of a shipment, blah, blah, blah. And then we have instead of calculating a 99%, we chose to calculate 95. So confidence interval it shrunk, basically. It would definitely get narrower. The margin of error will be the same. It cannot be the same because it just shrunk. It will have the same margin of error. Nope. Since the sample mean is a random sample, we cannot predict how the... Okay, we can because it's just going to get narrower. So 5 is a no-brainer. It's B. Suppose you're conducting a test of significance, which mean is 100. Which of the following tests against a specific alternate hypothesis is least power? So for power, just remember, n has to be, if n goes up, power goes up. If alpha goes up, power goes up. The difference between null and sample goes up, then the power goes up. So they all have what we call a direct relationship. If one goes up, the other one goes up. So if I want to find out the one with the least power, we have to pick the one that has the smallest n, smallest alpha. So even just by looking at these combinations, we're going to eliminate B and C because of the 60s. And we're going to eliminate the E and A because of the higher alpha value. And the correct answer here, it seems like it should be D for this one. All right, number 7, a 95% confidence interval for mu of B minus mu of A is given. Use the conservative value for the degrees of freedom. So what we have is B minus A, which means 109.1 minus 94.5. And then always remember that we need to have, first of all, this is going to be a T value test. This one doesn't even have the T value in the front, so we're going to eliminate them. But the formula basically goes S squared over N plus S2 squared over N, or we can just label as N1 and N2. The standard deviation for A and B, we have 10 and 9, so we must have the sample size of 10, 10 squared, 9 squared, so it seems like we're really looking between B or C. To find out the correct T value, go to inverse T, and since this is going to be a 95% confidence with 20 seedlings in total, but then we have separated the degrees of freedom with 10 for each of the samples because we have 2. So the degrees of freedom here should be 9, and the correct answer here should be C for number 7. All right, next one, number 8. You constructed 95% confidence interval for a mean and find out to be this, which of the following is true. So test for the hypothesis of 1.2. Okay, so this one is kind of tricky because what you want to say for these types of questions is that the mean is 1.1, and if the margin of error is 0.8, then means I go up by 0.8 and I go down by 0.8. So anything in here you are predicting as a true value will be contained with a 95% confidence. But if I want to find a hypothesis test, and if I wanted to reject the null hypothesis, because it seems like I wanted to reject it for all of these, I would only be able to reject if my null hypothesis it's deemed as ridiculous value. So look at all your null hypothesis values for this. 1.2, 1.1, I mean, they're all within the boundary. So you wouldn't be able to reject it at any reasonable level. If you picked C, this is the correct answer because notice how the null hypothesis said it's 0. See, the 0 is not even part of your 95% confidence interval, which means there's gonna be some sort of a value or a claim or enough p-value that would lead you to reject the null hypothesis and say, you know what, most likely this is not going to be true. 95% confident that the value is going to be between these two. And so if I'm trying to test to see if my null is going to be true, well, it's not, because we are 95% confident that the value will be between 0.3 and 1.9. So therefore, C is going to be incorrect for this question. Number 9, for this, what would the type 2 error be? The water dye requires you to drink 2 cups. Okay, so let's try to think about what this will have. The null hypothesis means that there will be no difference, and the alternative would mean that there would be a difference. Because what we're trying to see is weight before the diet and after 6 weeks, and we're probably going to compare the difference. And this, you basically lost 10 pounds, you actually gained 5 pounds, you lost 25 pounds, you gained 2 pounds. So by looking at these 4 numbers and by putting it through a test, would there be a sufficient evidence for you to say that there is a difference between the diet versus not diet? What would type 2 error be? Type 2 error, remember, it's when you fail to reject, but then what happens is that the alternative actually became true. So you claim that there is no difference between the diet of the weight before and after the diet, when in reality there is actually a difference. So concluding that the diet leads to weight loss when it really doesn't. Okay, so these two are not going to be the case, because first we want to conclude that it doesn't lead to any weight loss. Not concluding that the diet leads to weight loss, comma, when it does. So that should be C. An advertising firm, blah, 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 blah. So we have all the information that we need. We have an alpha, we have this, we have 0.0045 for our p-value. So p is less than alpha, so we reject the null. Which of the following is the correct interpretation of the p-value? If the null hypothesis is true, please note that anytime when they ask you to interpret the p-value, what it means that when the null hypothesis is true, the probability of getting a difference in the sample means as farther from 0 as the difference in our samples is 0.0045. This is the context of the alternative hypothesis, because what we're trying to say is we're trying to see if it's different from 0. Your chance of being able to support alternate hypothesis, 0.0045. So that correct answer here should be D. Suppose we're testing the null hypothesis, mu is 50, mu is not 50 for normal population, t is 1.39. Which of the following intervals contains the p-value for this test? Okay, 9 observations, so we have this and we have this. We can find the degrees of freedom would be 8, and it seems like we have to use TCDF for this. So second bars, and then we're going to do TCDF with 1.39, and the upper values, we can just put a bunch of 9s in there with degrees of freedom, and it allows to calculate the 0.10 as our p-value. So our p-value is somewhere between 0.1 and 0.2. So 11 here, therefore, should be D. Number 12, does listening to music increase the speed at which people complete routine tasks? So we have all the differences for the 15 samples. So degrees of freedom is 14. We wish to, this is supposed to be a typo, we wish to test the hypothesis that the mean difference in time to sort the beats with and without music is 0. Which of the following is the appropriate test statistic? So, the difference between these two, 19 minus 18.6 minus 0 technically, because that's the difference of the null, over, now the square root. Now this is where you have to be very careful, because the standard deviation for the first and the second, 5.13 squared and 5.04 squared, but then they will both be divided by the sample size of 15 for both of them. And so the whole thing should look like this. And so here, D and E just obviously makes no sense because it doesn't have a square root over the whole thing. The correct answer here should be A for number 12. Oh, my apologies. Okay, so this is gonna be for the differences, and so it's the mean of difference over the standard deviation of difference over square root of n difference. So here's what it's gonna look like. Now, for this type of particular question, this is the formula that you're going to be using for the difference of the two. So we're not going to be focused on any of the mean and the standard deviation of the samples. Rather, we're going to be really focused on the difference here. So the mean here would be 0.4 with the standard deviation of 1.96 and the square root of 15 because that's still the sample size of the difference. And so the correct answer here should be E. Just that simple. Number 13, there are large number of jobs available town A and B, and which of the following is not true about the construction of the confidence interval? It says, it's necessary to assume that the samples are independent and random. It is necessary to assume that the population distribution is normal. Nope, this is not true because it doesn't matter what the shape of the population is because the shape of sample distribution is always going to be normal anyways, so it's not necessary that the population distribution is normal. Now, as long as the population is or the sample size is greater than 30, we can just assume normality from sampling distribution anyways. So it's not it's not a must situation. So B should be the correct answer. Yes, it is necessary for make sure that to assume independence and randomness so that we don't get a biased result. T distribution could be used because we don't know what sigma is, so that's absolutely true. The quantity of mean of A, the sample mean of A minus sample mean of B will lie at the center of the interval. That's absolutely true. If a larger sample has been used, the confidence interval would probably have been narrower. And as you know, as long as n goes up, the interval or the variability goes down. So in other words, the confidence interval also gets narrower because our values or our data gets much more accurate. So therefore it's B. And number 14, we have a simple random sample selected from the population. We have a 95% confidence interval for the population mean to be found 58.7, 61.42. If the significance of 0.05 is used, which of the following is true? Now, this is very similar to the one that we've done before. It's similar to question number 8, where you're trying to look for a null hypothesis that's kind of ridiculous and it's not part of your confidence interval. Now notice how all of your null would be rejected for most of these answers except for the last one. If I want the null to be rejected, that means my null value has to be somewhat of a ridiculous value. Remember, our confidence interval, a 95% confidence interval, is anywhere between 58.7 to 61.4. There is honestly just one, two values that I see. It's 57 and 62 that is outside of the realm of the confidence interval. So I'm going to eliminate C and D because C and D are just right in the confidence interval, so I don't think you're going to be able to reject that claim. 62, which is right here, so it is outside the confidence interval, but it says the null would not be rejected. Well, if you find this claim, then the null would be rejected because what we have is a confidence interval that captures the true value is somewhere going to be between 58 and 61, but you got a 62, so that doesn't really match with your confidence interval, so therefore E cannot be the right answer. Between A and B, the correct answer here would be B, because if we're talking about 57 and the alternative to be wait a minute, sorry about that, because mean less than 57 is actually much more ridiculous because that is not part of your confidence interval. So the correct answer here should have been A. So the null would be rejected against alternative, which says that the mean is actually not 57. When the mean is not 57, it means that any value other than 57 will do. So which does contain the confidence interval is contained within this alternate hypothesis. So A should be the correct answer. B, when it says it's less than 57, the confidence interval is not contained within this boundary for B. So therefore, B is actually out of the question. So there we go. There we have it. Okay, so let's do free response question. Construct 99% confidence interval. So state, we are constructing a 99% confidence interval to capture the true mean weight of cashews in one bag. You guys get the idea. Now, planning, do we have random samples? Yes, we do. We have a random sample of 16 bags. It's clearly stated right here. Next, the 10% rule states that the capital N has to be greater than 160, which I believe that this manufacturing plant will make. Sometimes I ask you guys for a sentence here because just to explain, like, you know, a reasonable, like, why would this make sense? Because the manufacturing plant makes more than 160 bags of cashews, we can assume. So we can assume that the manufacturing plant makes more than 160 bags of cashews in this example. And then the last one is making sure that the sample size is greater than 30, which clearly we don't have. But that's what the dot plot is for, right? Since 16 is less than 30, the dot plot shows no extreme skewness / outliers. Therefore, we can proceed with the next step. As long as it's fairly symmetrical, it's totally okay. Next, we have the do portion, which we are constructing a 99% confidence interval. And this is going to be a T interval, so stat test. And it seems like we have T interval here. We're going to use stats. The mean of all of these 16 bags of cashews was 14.6, with a standard deviation of 0.6 and a sample size of 16. And we're constructing a confidence interval of 99%. So to do, we are going to write down 14.158, comma 15.042. And let's not forget the degree of freedom here that we have to use for the t-test. We could use 15 because it's n minus 1. However, we still have to write down that the mean, which we are trying to capture, the sample mean plus and minus the t times the square root times the sample standard deviation over square root of n. This should be the confidence interval for this one sample. So if I plug in all those values, we get 14.6 plus and minus the t star, which we still don't have, but we will figure that out eventually. The standard deviation of 0.6 with the standard with the square root of 16. Now, how do you find out the t value? Well, we have degrees of freedom here. So second vars, inverse t, area of 0.995 because of the 99% and the 15. And we have a t value of 2.946. A lot of you guys on the test use 2.95, which I gave you full credit for. And even if you don't get the exact same numbers on your test, it should be okay as long as it's close to it. And then for this, for the last part, conclude, we are 99% confident that the true mean value of weight of cashews in a bag is captured within the interval 14.158, comma 15.042. And that should do it. All right, last question, number 2. So we have all the data that we need. We have 2 samples, and it seems like the music group versus the no music group. Is there convincing evidence that listening to music increases the average number of turns? Okay, So these are just the number of turns, it seems like. So from the data, we just have to get our head around the fact that listening to music actually do waste more time. They actually do take more turns. That's what this number shows. So for state, we have to do our null and alternative hypothesis that the mean with the music minus the mean with no music will equal 0. The mean music minus mean with no music will be greater than 0. This proves that for alternative that it's going to take more average number of turns to complete this memory game. Where the mean music represents sample mean for music, this represents sample mean for no music. All right, so we have that out of the way. So for planning, again, random samples we have. It seems that we have 84 volunteers and randomly assigns them into 2 groups. So the element of randomness is there. Next, the 10% rule. Since we have a sample size of 84, do we have more than 840 students for the capital N? Yes, we do. It seems like we're talking about a school. So the total population exceeds 840 or reasonably so. And then the last one here, which is the N is greater than or equal to 30, which means 42 is greater than or equal to 30, and then 42 is greater than or equal to 30 for both of the samples, so they should be okay. All right, so now let's do the do portion here. So for the do portion, we are constructing a 2-sample t-test for difference in means. And then that's what we're gonna do. So we're gonna go to our calculator, stat tests, and then 2-sample t-test, which is right here. The mean of the first one, 15.833, standard deviation of 3.944, 42, 13.714, 3.550, the mean of 42. Now, what we want is that the mean of the first one will be greater than the second mean, because the more turns it will take for music, not the one without the music. For pulled, say no, press calculate. So the p-value is 0.005, t-value 2.587, degrees of freedom is 81.10. Make sure you just write down all of these other numbers because they're also quite important in you getting full credit. So since p is less than alpha, we reject the null. There is convincing evidence that h sub a is true, and I'm just going to abbreviate it like that. H sub a being the context of this, where the taking the music, listening to music versus not listening to music, it actually do require more turns to complete the memory game. Given your conclusion in part A, which type of error? Obviously, since we rejected the null, the only possible error is type 1 error. So what does that mean? It means that we rejected the null, but then actually the null is true. We thought that music increases number of turns required to complete the memory game, when in reality, music or no music requires about the same number of turns. So what that means is you rejected the null, saying that, you know what, music does increase the number of turns, it gets you distracted more, but then when in reality, it was just about the same, because in reality, the null is true. So listening to music or not listening to music, they actually do end up as the same result of taking as much turn to complete the memory game. Okay, so hopefully this kind of cleared things up for you for chapter 10 and 11. Study the materials, please, and I'll see you guys next time.